All right, in today's lesson, we're going to look at operations of functions. And in order to be successful with doing the different types of operations of functions, you really need to start recognizing the different types of notations that you could see for various problems. There's really 5 different notations that we're going to be looking at today. The first 4 are just your basic operations. So we have addition, subtraction, multiplication, and division. Starting with addition, if you see f plus g of x, that's saying I have a function f and a function g. If I'm adding it, it's saying take f of x, add it to g of x. With subtraction, f minus g of x is really f of x minus g of x. With multiplication, f times g of x is really f of x times g of x. And then with division, we have f divided by g of x is really f of x over g of x. And you need to make a quick note, g of x cannot be equal to 0. And that's because if you recall with fractions, we can't divide a fraction by 0. You can never have 0 in the denominator of a fraction. It's always undefined. And the last part is composition of functions. Easiest way to describe a composition, it's a function within a function. So for instance, f of g of x is saying find the value of g of x and then take that value, plug it into our function f. We'll go through some practice problems, and the more practice you do with this, the better off you're going to be. So let's go ahead and scroll down to the bottom here. It says use the tables below to evaluate each of the expressions. This first table we have f of x, and in the second table we have g of x. So just make sure you're corresponding to the correct table when doing these problems. So number 1, we're finding f of 0. So I'm going to my function f of x. The input value is 0. What do we get out? We get out -8. Number 2, g of x equals -2. So this time they're saying my output value is -2. So 1 is my output value, -2, when x is 4. All right, number 3, f of 2. So f of 2 gives me out -9 plus 3 times g of -2. So we got to go to now our function g. X is -2, we get out 6. So we have -9 plus 3 times 6, so -9 plus 18, which is 9. Number 4, erase that. Number 4, we got g of 5, so let's sign g of 5. So when I plug 5 in, I get out 7. And we're multiplying that by f of 1. So when I plug 1 into my function f, I get out 2. 7 times 2 is 14. All right, here's our first composition, number 5. It says g of f of -1. So when you're doing these composition functions, think you're working from the inside out. So we got to do f of -1 first. So f of -1, so when I plug -1 in, I get out 7. So I'm going to do g of 7. So notice f of -1 was 7. Remember what I said, composition is a function within a function. So I'm finding the value, the output value for when my input value is -1 for my function f. That was 7. Now I'm going to plug 7 into my function g. So when I plug 7 into my function of g, we get out 15. Let's go ahead and erase this. And our last one, we got number 6. We got f of g of 4. So first we're going to do g of 4. So when I plug 4 in, I get out -2. Now we got to take f of -2. So f of -2, when I plug -2 into my function f, I get out 5. All right, moving forward, it says use the graphs of f of x, g of x, and h of x below to evaluate each of these expressions. So we have 3 different functions. Number 7, we're using f and g, so we have f of -3, so I'm going to go to my function f. My input value at -3 gives me an output value of 2 plus g of 3, so at 3 on function g, I get out a value of 3. So 2 plus 3 is 5. Number 8, g of 2. So at x is 2, I get out a value of 4. And I'm timesing that by h of 1. So h is my third function here on the right. X value is 1. What do we get out? 5, 6, 7, 8. 4 times 8 is 32. Number 9, it says take 5, multiply it by f of 4. So let's go to f of 4. So when I plug 4 in, I get out a y value of -1 minus 3 times h of -1. So go to our function h at -1. We get out a y value of -1, 2, 3, 4, 5, 6, 7, 8. Get out a y value of -8. So we have -5. And then we have -3 times -8, which is positive 24, which is 19. Number 10, g of 5. So I'll go to our middle function g. X is 5. We get out a y value at -4. H of 6. So our third function, when x is 6, we get out a y value of 1, 2, 3. So we have -4/3. And that, if that fraction can be reduced, guys, make sure you reduce it. Number 11, we have a function within a function within a function. All right, so again, when you're doing these, work from the inside out. So let's start with f of 5. What's f of 5? So when x is 5 for my function f, I get out a y value of -1. So I have h of g of -1. So now let's do g of -1. So go to our second function g. When x is -1, we get out a y value of 1. So g of -1 is 1. Now we got to do h of 1. So h of 1 gives me, at 1, we get out 8. Number 12, g of f of h of 5. So again, inside out. So h of 5. 5 is 0. So f of 0, and then we're going to take g of that. F of 0 is, let's go to our first graph. At 0, we get out a value of 2. So now we're going to do g of 2. And at g of 2, we get out a value of 4. All right, and now the bottom says use these 3 functions, f, g, and h, to evaluate each of the expressions. So here's that notation that I was talking about. Number 13, we have f plus h of -3. So that's telling us to take f of -3 and then add it to h of -3. So f of -3, I'm going to do 4 times -3 plus 10. And I'm going to add that to h of -3. So I got to plug -3 in for x into my function h, which would be -3 to the 4th plus 1. Let's clean this up. 4 times -3 is -12 plus 10 is -2 plus -3 to the 4th. Now when you take a negative base to an even power, or multiply it by itself, in this case 4 times, you're going to get out a positive value of 81 plus 1. So we got 81 plus 1 is 82, minus 2 is 80. Number 14, g of 4 minus f of 1. So g of 4 is going to be 2 times 4 squared plus 4. Notice again, I'm using those parentheses, minus f of 1. So I'm going to plug 1 in for x into my function f. So order of operations, remember, please excuse my dear Aunt Sally when simplifying. So parentheses first, 4 squared is 16 times 2 is 32. 32 plus 4 is 36. Minus 4 times 1 is 4, plus 10 is 14. 36 minus 14 is 22. All right, and our last one, number 15. We have 5 times f of a plus 2. So 5 times f of a plus 2. That means I'm plugging a plus 2 in for x. So 4 times a plus 2 plus 10 minus g of a plus 1, so g is 2x squared plus x, so it's 2 times a plus 1 squared plus a plus 1. Let's clean this up a little bit. So we have 5. 4a plus 8 plus 10 is 4a plus 18 minus 2. Now a plus 1 squared, I got to FOIL that. A squared plus 2a plus 1. Change that, I don't want a bracket there. 2a plus 1, and then we have plus a plus 1. So 5 times 4a is 20a. 5 times 18 is 90. Minus, now on the inside I got to distribute, so that's 2a squared plus 4a plus 2 plus a plus 1. Let's clean that up. So we got 20a plus 90 minus 2a squared. So I'm just distributing this minus sign. Minus 4a minus 2 minus a minus 1. So when we write this, we should write it in standard form. So highest exponent down, so negative 2a squared. 20a and negative 4a is positive 16a. And then we got 90 minus 2 is 88. Minus 1 is 87. Minus 9, 78. And that would be our answer.